Welcome to Math with Professor V. In this video, we're going to learn how to do synthetic division. Now, synthetic division is a lot easier than polynomial long division. So if you don't know this method yet, stay tuned. It's going to be a game changer. Only catch is you can't always use synthetic division. We can use it as long as our divisor, the thing we're dividing by, has the form x minus c. And I'm going to show you a variety of examples so you can identify what c is and how to proceed. And then the process, it's too lengthy for me to list it out for you. It's best learned by observation. But basically you put c on the left, you put the coefficients of the dividend, the thing you're dividing into, in a row, and then leave a blank row beneath it. And then the process unfolds pretty straightforward, but just watch and you'll get the hang of it in no time. So here we go. First example, we're going to divide this polynomial here by x minus 2. And notice I'm allowed to do synthetic division because my divisor is of the form x minus c. So in this case, c is equal to 2. So I'm going to put that over here on the left. And the way I was taught, we put like this little open kind of square. Other people do it differently, and it doesn't really matter, just so long as that number's on the left somewhere, okay? Then you put the coefficients of what you're dividing into. This is called the dividend. So 3, 5, negative 2, 7. Don't put the variables with it. Just 3, 5, negative 2, 7. Good? Then you need a blank row. So leave yourself some space here. And then I put a line here just to keep everything nice and neat, and you'll see what's going to happen. So starting on the left, this is always the same. Whatever number is there, whatever constant is there, you just bring it down and rewrite it beneath that horizontal line. Okay? Then here's the process, and you just keep repeating it. You take C, the number in the little box, and you multiply always by whatever number is here underneath that horizontal line. So 2 times 3, that's 6. I list that in the next column, moving one column at a time. So I'm going to list it here. 2 times 3 is 6. Then what I do is I add vertically. You always take these two entries, add them, list the result below. So 5 plus 6, that's 11. And then now you repeat. So then here's 11. I multiply by c. You always multiply by c. And then list the result in the next column. So 11 times 2, that's 22. And then add vertically. Negative 2 plus 22 is 20. And then repeat. So we're going to take this entry here, multiply by 2. 20 times 2, I'm going to list that here. That's 40. And then add vertically, 40 plus 7, 47. Good? Did you follow the process so far? Okay, this last number right here, this is our remainder. And then 3, 11, and 20 are the coefficients of our quotient. So the quotient is always going to be 1 degree lower than the polynomial you were dividing into. That should make sense because if you have a degree 3 polynomial and you're always dividing by a linear factor, x to the first, it's always going to go down by 1 degree. So this is going to be the coefficient of x squared. This is the coefficient of x to the first, and this is our constant term. So we can list it out like this: 3x squared plus 11x plus 20. And it really depends too how the instructions are given for your division problem. If it says give the quotient and remainder, then you would just list it like this. If there weren't really any specific directions like I'm doing and it just says divide, then let me show you how I would write my answer. I would write the final result as the quotient. And then you put plus whatever the remainder was, in this case 47, divided by the divisor, or over the divisor, in this case x minus 2. Just like you do when you're dividing fractions and you have a remainder and you put the remainder over the number that was out front, same idea. Okay, so just see how you're instructed to report your answer. Sometimes they'll say give the quotient and the remainder separately like that, but if it just says divide, then technically this is the way you should write it. Okay. Very good. Let's practice some more. I don't expect you to be a professional after one example, but certainly just after a few, I think you'll be there. Okay, example 2, we're dividing 4x cubed minus x squared plus 6x minus 8 by x plus 3. Now, I know I said the divisor had to have the form x minus c. So if you're caught off guard a wee bit because it's x plus 3, don't fret. X plus 3 is the same as x minus negative 3, right? So in this case, c is negative 3. If that freaks you out too much, you want another option, you just take x plus 3, set it equal to 0, solve for x. So then c is negative 3. That's what goes over here on the left. Just the opposite basically of what you see, okay? Now we're gonna list just the coefficients of what we're dividing into, the dividend. So 4, -1, 6, -8, okay? 4, -1, 6, -8. Then leave yourself a blank row. I draw a horizontal line, and then we start all the way on the left. So just bring down this first entry, don't touch it. Next step, multiply -3 by 4. List that result in the next column to the right. So that's going to be -12. Then you add vertically, -1 plus -12, that's -13. Then repeat, so -3 times -13, that's +39. Add vertically, 6 plus 39, that's 45. 45 times -3. 45 times 3, I think of when I used to squat a lot of plates, right? Do you add in 45s easily? Okay, anyways, it's going to be -135. And then -8 plus -135, -143. Okay, this right here, this is my remainder. And then originally our polynomial was degree 3. So our quotient is degree 2. The coefficients of the quotient are right here. So it's going to be 4x squared minus 13x plus 45. That's the quotient. Now, if they want just general, what's the result from dividing? Don't give the quotient and remainder separately. Then you should write 4x squared minus 13x plus 45. Since the remainder is negative, I'm going to put minus and then 143 over x plus 3 like that. Ooh, so fancy. Do you love it? Okay, good. Let's try a few more. And I have just a couple interesting scenarios that you got to be aware of. Notice here, I'm dividing, this time it's degree 4, we're getting fancy. And then I don't have an x squared term. So I need to put a placeholder. I'm gonna need to put a 0 when I'm listing the coefficients here, okay? So anytime there's a term missing, when you're listing from the highest to the lowest term in descending powers, you have to put a 0 to account for it. All right, what's c equal to here? X minus c, c is 1, right? Okay, so put 1 over here, positive 1. And then now I'm going to list the coefficients 5, -3, 0, don't forget that, 2, -4. Honestly, forgetting placeholders is probably the most common mistake I see students make because once they get the hang of this process, they don't mess it up. Okay, here we go. So just bring down the 5. Then we multiply 1 times 5, that's 5, that's going to go here. Then add vertically, -3 plus 5 is 2. Multiply 1 times 2, list that here, that's 2. Add vertically, 0 plus 2 is 2. Multiply on the diagonal, 1 times 2 is 2. Add vertically, 2 plus 2, 4. Multiply 1 times 4, and then add vertically, -4 plus 4, 0. So this means we have 0 remainder, which actually tells us that x minus 1 is a factor of this polynomial. That's the factor theorem. If you need to review factor theorem or any of those pre-calc topics, I have full-length video lectures, and I'll link a couple videos in the description, but I digress. So here's the, here's the quotient, at least its coefficients. So we can say it's 5x cubed this time, right? Since we started with a degree 4 polynomial, this is one lower. 5x cubed plus 2x squared plus 2x plus 4. And there's no remainder, so there's only one way to write out the final answer. The quotient is as is. There's no remainder to attach to this guy. How beautiful. Okay, are we good? Let's try another one. Here we're dividing x plus 2 into 2x cubed plus x squared minus 7x plus 5. I just wanted to show you, if they start you off and it looks like a long division problem, doesn't mean you have to take their bait. You know what I mean? You just go, hey, this is of the form x minus c. c is negative 2. I'm going to do synthetic instead. 2, 1, negative 7, 5. Okay. Why don't you pause the video, try this one on your own, see if you can do it. Excuse that crooked line. Did you try? Did you get remainder 7? Good. Okay, bring down the 2. Negative 2 times 2 is negative 4. Add vertically 1 plus negative 4, negative 3. Multiply on the diagonal, negative 2 times negative 3, that's positive 6. Negative 7 plus 6, negative 1. Then we have negative 2 times negative 1. That goes here. That's 2. And then add vertically 7. So there's my remainder. And then my quotient is degree 2. Here it's going to be 2x squared minus 3x minus 1. That's my quotient. So you could leave it like that, or if we're going to put it all together, I would write it as 2x squared minus 3x minus 1 plus 7 over x plus 2. Beautiful. How are you guys doing? I feel like you're doing well over there for some reason. That's the vibe I'm getting. Okay, here's one where you need a placeholder, but it might not have been super obvious because look at this sneaky little guy. So this is degree 4, 4, 3, 2, 1, but there's no constant term. So you do still need to put a 0. Yes. And then the divisor is x minus 3, so c is 3. So put that 3 over here on the left. And then we're going to have 1, negative 6, 11, negative 6, 0 for the constant. Okay, here we go. So bring down the 1. Then we do 3 times 1. That's 3. Add vertically, negative 6 plus 3. That's negative 3. Then you multiply 3 times negative 3. That's negative 9. Add vertically, 11 plus negative 9, that's 2. 3 times 2, positive 6. Ooh, I always love it when I get 0 remainder, but keep it going. 3 times 0, 0, 0. So there's my remainder, 0, fab. Here's my quotient. It's degree 3, because I started with a degree 4 polynomial. X cubed, x squared, x to the first, and then, oh, my constant term's not even there, it's 0. So quotient, x cubed minus 3x squared plus 2x. That's it. You know what, let me box it the way I was boxing all the rest. It's not like this is a lesser problem. Here we go. Okay, beautiful. I got one last one for you. Okay, here we go. I would definitely try this one on my own if I were you. Okay, 3x to the 4th minus 8x cubed plus 5x minus 12 divided by x minus 4. So what's c? C is positive 4. Good. Put that over here. Now be careful listing the coefficients. Did you catch it? There's no x squared, so we got to put a placeholder. 0x squared. Don't forget that. So 3, negative 8, 0, 5, negative 12. Okay. So starting on the left, bring down that entry all the way there. Multiply 4 times 3, that's 12. Add vertically, negative 8 plus 12, 4. Multiply diagonally, 4 times 4, 16. Add vertically, 0 plus 16, 16. 4 times 16, 64. Add 5 plus 64, 69. Multiply 4 times 69, 276. Add vertically, negative 12 plus 276 is 264. That is the remainder. Okay, so then here's our quotient. What degree will it be? One lower than this guy, so it'll be degree 3. So this is 3x cubed plus 4x squared plus 16x plus 69. And then if they just said plain old divide, then you should write your answer as 3x cubed plus 4x squared plus 16x plus 69 plus remainder over divisor, x minus 4. Okay. Now you might be saying, Professor V, this is fantastic. Forget polynomial long division. It was a pain trying to master it. I would say I'm with you, except we can't always use synthetic division. So if I had made one slight adjustment to the divisor right here, and if instead it was x squared minus 4, then you can't do synthetic. And you're going to have to do division with nonlinear, expressions all the time. So if you needed to divide like 3x to the 4th minus 8x cubed plus 5x minus 12 by x squared plus 2x minus 1, this you cannot do using synthetic. You need to use polynomial long division, but don't fret. I have a video on that. So I'll link it in the description, and it's not too difficult to master. It is messier than this for sure. I'm with you. If I could do synthetic, I always pick synthetic over long division, but you got to know both. You can't be a one-trick pony, basically. All right. I hope this video was helpful. Give it a thumbs up, comment down below. Let me know what math class you're currently taking. I'm always curious who's watching these. Most of my viewers are in calculus, but I know that a lot of people need algebra review as well. So I'm happy to make videos on these topics as well. If you need full-length video lectures and you're in a math class, I have everything from Trig, Precalc through Calculus 1, 2, and 3. They're all organized into playlists. Happy browsing. And you can also follow me on Instagram and TikTok, Math with Professor V. I love you guys so much. I'll be back sooner than later. Bye.